In this video, we're going to go over a bunch of practice problems for the product and quotient rules. So first, let's recall the product and quotient rules. The product rule says that if you have two functions multiplied together and you take the derivative, fg prime is going to be f prime g plus f g prime. The quotient rule is if you have a function divided by another, take the derivative, that's going to be f prime g minus fg prime over g squared. This is what we're using in this video. All right, so first one, we have two functions multiplied together, a 3x squared and an e to the x. So the product rule says that I'm going to take the derivative of the first function times the second plus the first times the derivative of the second. And you may be able to do these derivatives in your head, but kind of breaking it up step by step allows us to not make mistakes as we're getting through more complicated problems. So now I have two more derivatives to do, and I can do each of those separately. So the derivative of 3x squared is 3 times 2x, which is going to be 6x. We have e to the x, 3x squared, and then the derivative of e to the x is our really nice function because it's just the same e to the x. And here is our answer. So let's do it again, as the next application is again going to be the product rule. We have two functions. The first one is x minus square root of x, and the second one is 4 to the x. So using the product rule, we're first going to do the derivative of the first, derivative of x minus square root of x times the second plus the first in parentheses times the derivative of the second. And again, this shows me that I have two more derivatives to take care of. So the derivative of x minus square root of x, note that we could write that as x minus x to the 1/2 power. And this derivative is just two applications of the power rule. So this is going to be 1 minus 1/2 x to the negative 1/2. Bring the power down out in front, decrease the power by 1. It's important that that's going to stay in parentheses, times 4 to the x plus x minus square root of x. And the derivative of 4 to the x is natural log of 4 times 4 to the x. And we won't be simplifying our answers too much as they can get very gross very quickly. Note that what you could have done is you could have distributed the 4 to the x to both terms, and you could have done the derivative that way, except that you just have to do the product rule twice with each of those terms separately. So that's doable, but it makes it more difficult. All right, let's go on. Now we have an application of the quotient rule. We have our top function is 1/2 to the x, and our bottom function is 2x cubed. So the quotient rule says that we are going to take the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. So once again, we have two derivatives to take care of. First of which is an exponential. We're going to have natural log of 1/2 times 1/2 to the x, and all of that times 2x cubed. And the second, we have 2x cubed, which is going to be a power rule. It's going to be 2 times 3x squared, which is 6x squared. All over the bottom squared, which you can write as 2 squared, which is 4, x cubed squared, which is x to the 6th. And we could do some simplification there, but we can just leave it like that, and that's going to be fine for what we're doing right now. When would you need to simplify is if you have to do something with that derivative. So maybe I asked you on what intervals is the function increasing or decreasing, then it would be very useful to simplify this as much as possible so that you can analyze it in some capacity. But if we're just finding derivatives and that's all we're doing, I'm not going to say that we need to simplify anything. All right, next problem. We again have some division here. Our top function, 15x plus 1, our bottom function, x squared minus 1. So, using the quotient rule, we have the derivative of the top times the bottom minus the top, and make sure that you have parentheses each step of the way here, otherwise it wouldn't be correct, times the derivative of the bottom all over the bottom squared. Once again, we have two more functions to take care of. That ddx is an instruction that we have more to do. So we're going to do the derivative of 15x plus 1. That's just 15 plus 0. All of that times x squared minus 1 minus 15x plus 1. The derivative of x squared minus 1 is the derivative of x squared minus the derivative of 1. That's going to be just 2x minus 0. And all this over x squared minus 1 quantity squared. So once again, I'm going to go through each of these problems step by step, writing out that intermediate step each time. That allows me to catch mistakes and to be a little cleaner in my work. Note that if I were just doing this on my own, I could just jump to the straight, right to the right answer. I understand these derivatives well enough, and you may be in that same boat. I urge you just to go slowly because as we get into more complicated problems where we have to do multiple rules at the same time, it's going to be nice to organize our thoughts. Next problem, we have a division again. We have x on the top and 1 plus e to the x on the bottom, and we're going to do the quotient rule here. So this is going to be the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom in parentheses squared. Take care of our two more derivatives, and we have 1, the derivative of x, so we'll just write 1 plus e to the x, minus x times the derivative of 1, which is 0, the derivative of e to the x, which is e to the x, all over 1 plus e to the x squared. And lastly, we have this derivative, which is going to use a couple different rules here. So we have to ask ourselves, as a whole, is this the multiplication of two functions or the division of two functions? And note that we do have multiplication here, right? We also have division. So which one takes priority? Which one should we take care of first? And again, as a whole, we have division with multiplication inside of it. So this is going to be the quotient rule first. But then if we do it correctly, we should have the product rule inside. So the top function is this whole thing, 5x plus 1 times 7 to the x. The bottom function is x squared minus x. You couldn't write it as one function times another, or at least not in a very nice way, to use the product rule with that 5x plus 1 and 7 to the x. So now let's do the quotient rule. This says that we are going to take the derivative of the entire top function, and I'm not going to try to do that yet. I'm just going to write down the derivative of the top times the bottom plus the top times the derivative of the bottom all over the bottom squared. And here's where breaking up these problems into multiple steps is very useful, because now when we look at our next thing to do, that's not a straightforward derivative. We have to use the product rule on that function. It's 5x plus 1 times 7 to the x. Whereas this one over here is just straightforward. We just use the power rule. So first, let's take care of the product rule. That's going to be the derivative of the first times the second plus the first times the derivative of the second. All of that times x squared minus x plus 5x plus 1, 7 to the x, and then times the derivative of x squared minus x, which is 2x minus 1, all over x squared minus x squared. And one more line here. Now we have two more derivatives to do. Both of these are pretty straightforward. So we have the derivative of 5x plus 1 is 5 times 7 to the x plus 5x plus 1. Derivative of 7 to the x is natural log of 7 to the x. All of that times x squared minus x. And then we're just going to copy everything else down. So 5x plus 1, 7 to the x, 2x minus 1, all over x squared minus x squared. So if you try to do that in one big step, it can get very confusing and lots of mistakes can happen because you have to do a product rule inside of a quotient rule. But if you break it up kind of one step at a time, when you look at what derivatives you have to do, you can take care of each of those individually. And then it just comes down to rewriting a bunch of stuff one step after the other. And we actually have one more problem to do. So this is find the equation line, the equation of the tangent line to the graph of f of x equals x plus 5 over 2x minus 3 at x equals 0. So let's remember that the equation of a tangent line is going to be y equals f of a plus f prime of a times x minus a. In this case, a is 0. So f of a is f of 0, and that's going to be 0 plus 5 over 2 times 0 minus 3. That is 5 over negative 3, or negative 5/3. In order to find f prime of a, I need to find the derivative first. And we're going to use the quotient rule there. So this derivative is going to be the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. So the derivative of x plus 5 is 1. That's going to be just a 2x minus 3 here. 1 times 2x minus 3 minus x plus 5 in parentheses times the derivative of 2x minus 3, which is just 2, all over 2x minus 3 squared. It may help to simplify that, since all we really need to do is find the derivative value at 0. Let's just plug in 0 at that point. We have 2 times 0 minus 3 minus 0 plus 5 times 2 all over 2 times 0 minus 3 squared. That is negative 3 minus 10 all over minus 3 squared, which is negative 13 over 9. So here is our f of a, here is our f prime of a. The equation of the tangent line will be y equals negative 5/3 minus 13/9 x minus 0, or just x. So this is a line with a slope of negative 13/9. We are decreasing at that point because the derivative is negative. In fact, this has a y-intercept of negative 5/3 as well.